about the properties of concrete. In my previous video I mentioned about PCC and RCC and what are the differences. Now let's look into the properties of concrete. The first property is compressive strength. It is denoted as FCK. It is a measure of the concrete's ability to resist loads that tend to compress it. Usually when we provide concrete for construction, when it is ready for construction, the first thing we check is whether it can resist loads or not, or else what's going to happen is that there will be failure in buildings which we cannot afford. So the property that we have to check in a concrete is its compressive strength, and to check the compressive strength, the formula is compressive strength equals failure load by the cross-sectional area. Next is the flexural strength or the tensile strength. It is a measure of an unreinforced concrete beam or slab to resist failure in bending. That is when we apply tensile loads, we measure the concrete strength by mentioning it as flexural strength. When tensile loads are applied, we measure it to check whether it can resist that failure while bending. The maximum at which it won't break is the flexural strength. This is the formula using compressive strength. FCR equals 0.7 square root of FCK, where FCK is the compressive strength. Next is elastic deformation. It is a change in shape of a material at low stress that is recoverable after the stress is removed, and we find the elastic moduli is equal to 5000 root of FCK. Here compressive strength has a huge importance in concrete, so it is an important property. In most of the properties, to calculate most of the strengths and elastic moduli and all, we use compressive strength. So to calculate elastic deformation or elastic moduli is equal to 5000 root of FCK. Next, we will be looking into shrinkage. The volumetric changes of concrete structures due to loss of moisture by evaporation is known as concrete shrinkage or shrinkage of concrete. When the pores of the concrete are filled, what's going to happen is that we might preheat it, but due to evaporation there will be loss of moisture. What's going to happen is that the concrete will start to shrink if we use a lot of water vapors there. So the volumetric change of the concrete when there's a loss of moisture by evaporation, it is known as shrinkage of concrete. Now it depends upon the type of cement and the properties of ingredients which are used. That is the aggregate, fine aggregate or coarse aggregate. It depends upon the properties of aggregates as well. Not only that, it depends upon the type of cement. And as per the code, the allowed shrinkage value is 0.0003 meter. Next is creep, deformation of a structure under sustained load taking into account other time-dependent deformations which are not associated with stress. This is the part when the stress is constant and the strain becomes abnormally high. That time the concrete undergoes such a property called creep. Next is the workability. It is a property of freshly mixed concrete which determines the ease and homogeneity with which it can be mixed, placed, consolidated without minimal loss of homogeneity. Like when we take freshly mixed concrete, when we mix it again or place it together and make it into form of concrete, we check its homogeneity. If it's homogeneous, that means the workability is good. That property is known as workability. Next is durability. May be defined as the ability of concrete to resist weathering action, chemical attack and abrasion while maintaining its desired engineering properties. Next is thermal expansion. This takes place when there is fluctuations in temperature. that is in thermal expansion, like when you heat it, like really heat it, the concrete can expand or contract. That's what we call as thermal expansion. It happens during high elevated temperatures. Now next is sulfate attack. It is a chemical breakdown mechanism where sulfate ions attack the components of cement paste. Cement paste consists of many cations, like cations of sulfate. So when it comes in when it comes in contact with the other ingredients, it forms some kind of gel which chemically disintegrates it. Next is the freezing and thawing. It occurs in concrete when water molecules in concrete freeze and expand beyond the volume constraints of the concrete. Uh, that is all for today. I hope you understood what I have talked about in properties of concrete. Thank you.